Hello, Honors Algebra 2, and welcome to another thrilling installment of Chapter 5, Word Problems. How do you apply some of what has been learned in Chapter 5? I know that's been a big question on many of your minds. Here are some basic applications of these, but most of the skills that we learned in Chapter 5 are just to help prepare you and strengthen your brain for what's to come. So, example 1 here, container ship is being unloaded by 2 cranes. A new model crane can unload the container ship in 10 hours. An older model takes 14. If the new crane started to unload the ship at noon and was joined by the older crane at 2, at what time was the unloading job completed? So at what time, so our variable we're solving for is t in hours, and that's what we want to know. Maybe you will work at this particular shipping yard and your boss wants to know what time the job will be done. Okay, so we have 2 things going on here. We have this new model crane that can unload the container ship in 10 hours. And then its buddy comes along and it's an older model crane and it can unload the container ship in 14 hours. Okay. So as we start to figure out what's being done here, really what we have is for the unloading job, we have crane A working. Okay. And then 2 hours later, crane B. And then the job gets done. Okay, so how we can represent some of this stuff here, we know that the new model of crane can unload the container ship in 10 hours. So if we think of it, we can think of crane A as time over 10. That is however long it's been working on this particular job. Now 2 hours later, crane B joins the party. So whatever time that crane A has been working, we can think of this, it's going to work 2 hours less. So t minus 2, and it takes this crane 14 hours. So t over 10 plus crane B is t minus 2 over 14. And what we know is that the entire job is just 1. Okay, so to get the job done, that's 1 job, so it equals 1. Once you have that set up, really it's just going to be a problem of adding fractions, solving for t. So we're going to multiply each side by the LCM. The LCM in this case is 70. That's what 10 and 14 each go into. So if we do that to all 3 things, boom, 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 we end up with 7t plus 70 over 14 is, I believe, 5. Yep. 5 times the quantity t minus 2 and equals 70. Distribute 7t plus 5t minus 10 equals 70. 80 is equal to 12t. And divide by 12. What we end up with, 80 over 12, is 6.6 repeating, roughly 6, or you can think of it as 6 2/3 hours. If you want to be really fancy, you could, of course, convert that into a regular time, which is 6 hours, 40 minutes. But that's okay. I would accept either answer. So setting it up, I think, as usual, is one of the hardest things to do. Okay, let's look at another example. So pump A can unload the lunar petro. What is the lunar petro? I got this from the textbook. Maybe look that up and let me know what that is for a Dvorsky dollar, the lunar petro. In 30 hours, pump B can unload in 24 hours. Because of an approaching storm, both pumps were used. Okay, how long did they take to empty this ship? So this time we have pump A, boop, boop, plus pump B, and we need to unload 1 ship. Okay, well, pump A, it works at a time of t over 30. Pump B, they're starting at the same exact time. So like, hey, this storm's coming, we gotta get this job done. So it's gonna be T over 24. It doesn't start later like our first one. And that's gonna equal 1. This time, LCM 30 and 24. What do both of those go into? I'm gonna use a little calculator trick, if you remember that. Math, down to, or over to num, down to LCM. 30, comma 24, 120. So LCM is 120. Multiply all those by the 120. over 30 is simply 4t plus 120 divided by 24 is 5t equals 120. We have 9t is equal to 120. And 120 divided by 9 is approximately 13.3. You could again write it as 13 1/3 hours, or 13 hours and 20 minutes. Okay, so that's the main idea. Number 3 is very similar to number 2, and number 4 is also rather similar. Wonder why there's some stars next to that one there. Okay, try these out. So I'll let you pause the video here and try those out, but I will still go through them, and you can check your answers at the end. Okay, so old conveyor belt is 21 hours. Little curveball in that one, 21 kilometers. Okay. Okay, so that is the main idea. Take a look back at some of those problems. There are some extra ones thrown in the textbook, I believe. So if you are really struggling with those still, of course, ask some questions. But I believe that is the main idea as to how to do some of these word problems. So good luck, have fun, thanks for watching.